So we did 6.1 and 6.2, and we're skipping over 6.3 and 6.4. That'll get packaged into the next unit. And we have to do 6.5 and 6.6. So we're going to do 6.6 and then 6.5 because they don't really depend on each other. And 6.5 is shorter. So if we have that quiz that day, that leaves more time for the quiz. So we're going now we have to do equations. I mean, the first two sections were all about expressions, simplifying, doing operations with expressions. So the two things we haven't done yet, we haven't solved equations or graphed functions. That's what the last two are. This is the how do you solve radical functions. The extra credit homework at the beginning of this unit, right, assigned after the test, you had to copy down the steps for how do you solve radical equations. And this is more or less what it says, right? Number one, isolate the radical. And we know sometimes the radical is actually rational exponent form. But whatever form it's in, isolate the radical. Okay. Then, undo the radical. Meaning, if it's a square root, square both sides. If it's a cubed root, cube both sides. If it's x to the 3/2, then raise both sides to the 2/3 power. So whatever it is, you just have to do whatever undoes that radical. And then you have to solve the equation that's left. You know, most of the time, it's going to be some linear equation, something that you can use pretty basic algebra with. I mean, we'll get to one or two here where you have to use quadratic form, or it's a quadratic, so you solve by factoring or whatever way we solve quadratics. So you know, just do what's appropriate at that step. And I didn't add this last one here. I mean, you could say check. But that'll come up later, and we'll talk about why. When it is you really have to check. So it's pretty three concise steps. Isolate, undo, solve. So here's an example of a radical. It's already isolated, so I have to undo it. How do you undo a cubed root? You cube both sides, right? So let me fill that in. That'll be, change. So that'll be like this. The third root of 2x plus 7 cubed equals 3 cubed, right? So the cube of a cubed root, they cancel each other out. You just get the 2x plus 7. And 3 to the third is 27. So this is where you get to step 3, which is solve what's left. And this is a basic algebra 1 kind of equation, right? Subtract 7, divide by 2. And again, you could check 2 times 10 plus 7 is 27. The cube root is 3. It checks. So try that one. So what did you do to undo the radical? Square both sides. So that's x plus 25 equals 16. Subtract 25, x equals negative 9. Okay, here's one where I got to actually do some isolating, right? The cube root of x is not alone. It's got a minus 9, so I have to add 9. The cubed root of x equals 8. Okay, how do I undo the radical? Cube both sides. So x equals $512. So try that one. So what'd you do to isolate? Divide by 2, right? Divide by 2. Divide by 2. So now we've got the third root of x minus 3 equals 2. How do you undo a cubed root? Again, you cube it. So now I've got x minus 3 equals 8. So x equals 11. Kind of all too easy. All right. So here's a kind of related real-world problem, right? We all know about hurricanes around here. Right? In a hurricane, the mean sustained wind velocity, V, in meters per second is given by this equation. Now understand that this V, parentheses P, that's like saying F of X, right? It's not V times P. It's saying V is a function of P. The velocity is a function of the pressure, right? So don't think that that's like a multiply times P, because it's not. You know, if it caused problems, you can just like, okay, then just get rid of the P. Okay, now it's velocity. So V equals 6.3 times 1013 minus P. And P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So what does that represent again? Is this the P or the V? It's the V, right? So you put it in 54.5 equals 6.3 times the square root of 10,000 or 1013 minus P. Okay, so now you have to solve it. How do I isolate the radical? Divide by 6.3. So now we're going to have the square root of 1013 minus P equals 54, was it 8.65? Okay, so we've isolated the radical. Well, first of all, notice I switch sides there. What property says that I can switch sides? No. Commutative is like saying 2 plus 3 equals 3 plus 2. No equal sign involved. Say again. Not reflexive, but you're on track. There's two of them that are kind of considered together. Symmetric property. Symmetric property says that you can switch sides. Okay, so now we have to square both sides, right? So squared gives us 1013 minus P equals 74, and I'm just going to say 74.8. That's correct, 74.8. Okay, so we still got to solve, so let's subtract 1013. Negative 938.2. And that means P equals positive 938.2. So when the central pressure gets down that low, the mean sustained wind velocity is 54.5. It doesn't quite explain like where is that wind, I mean, we know the hurricane's a big thing, you know. Is it in the center? Is it in the eye of the storm? Probably not. That's where it gets calm, you know, in the eye. You know, is it at the, you know, once you get right outside the eye? It says something about being a mean sustained wind. So is it some band, you know, that goes a certain distance of miles? There's more to this story, basically. There's got to be. But you know, what is our pressure usually? You know, what's like the average surface pressure? (1013). That is the average surface pressure right there. Sea surface pressure, or sea level surface pressure, 1013. Okay, so now we have a radical, but it's not in radical form. It's in rational exponent form. Okay, so first I have to isolate it. Divide by 4. And that'll give me x to the 3/2 equals 27. Again, you keep seeing these same numbers all the time. Okay, now how do I undo raising something to the 3/2 power? Say again? You raise both sides to the reciprocal power, right? So it's x to the 3/2 to the 2/3 equals 27 to the 2/3. Whatever I do to one side, I got to do to the other. Okay, now what is the operation when you raise a power to a power? What's going on in between these two here? So multiply, right? And 3/2 times 2/3, when you multiply a number by its reciprocal, you get 1. So that's why we just get x to the 1. And what is 27 to the 2/3? 18? What's the cubed root of 27? 3. What's 3 squared? 9, right? 9. So try to do that one. So what did you do first? Divide by 3, and that gave you x to the 3/2 equals 125. Then how did you undo raising something to the 3/2? You raised to the 2/3. So x equals 125 to the 2/3. Right, so what is the cube root of 125? 5. What is 5 squared? Oh, sorry. So divided by 3, raised to the 2/3, so I'm just editing to show that part. 125 to the 2/3 is 25. Now, you know, I've taught this stuff many times, and usually out of different books. And the way this book treats this stuff, they've made it like easier than I'm used to. I think even most of you probably think this is not hard. Anybody said radical stuff is difficult, just doesn't seem that hard. Here's an example where something that they don't have any examples of this in the book, but usually they would at this point. It's not critical. I'll show you. It's not critical, but you know, if I have 3x to the 2/3 equals 75, similar problem, right? I would first start out, I divide by 3, right? So I get x to the 2/3 equals 25. And then how would I undo raising to the 2/3 power? I would raise both sides to the 3/2 power. So this is what that would look like. X to the 2/3 to the 3/2 equals 25 to to the 3/2. Okay, now, on the left, when I'm raising to the 3/2 power, what does that 2 in the denominator tell me to do? It's a square root, right? And we encountered in the last lesson, again, but this book doesn't really talk about this much, when you see an even root, it's supposed to be positive, right? So that is an even root. So if I cancel, if I say 2/3 times 3/2, that just gives me an x. Well, what if x is negative? Well, that would be a problem. So that's why, and we saw this on a slide in the last lesson, that's why you would have to use absolute value symbols around the x to make sure that it's positive. Right? Now 25 to the 3/2 is 125. Right? But now, what are the solutions to this? Either x equals 125 or x equals negative 125. Because when you take the absolute value, that would flip the sign. So you end up with 2 answers. So that could happen anytime you have to raise to an exponent that has an even denominator. Okay, well look at the ones we've dealt with so far. That one had an odd numerator, so when I raise it to the reciprocal power, it would be an odd denominator. That thing too, 3 in the numerator, which means there'll be a 3 in the denominator. Okay, this one I made it so that it would be even, but actually they have no examples, not in the homework, not in any of the examples in the section, where you would end up having to do what we just did there. And usually that's kind of a big part of it, but it is what it is. I mean, I'll show you this. This is the 2014 released SOL. It's one of the ones we use a lot when we're getting in that last bit when we're preparing. And what you'll notice is there's a fair number of radicals. I mean, clearly there's a lot of radicals. Like they actually, both of their examples are radicals. But if you look at them, I think you'll see that's not that hard. In the end, you probably feel pretty comfortable with what you know right now if you had to solve that, right? Or simplify, or to solve that equation there. Add 3, square both sides. Okay, not that one. How about that one? Subtracting radicals that don't look like radicals, but if you simplify, they will be. Okay, there's one. This is more about the converting from radical to rational exponent form, right? Which one of these rational exponent forms is the same thing as that? I mean, as long as you've got the index. The index is the denominators. The numerators are the powers, 15 and 17. And then the 4th root of 16 is 2. So that would have given us that one right there. Not that one. Well, that's kind of related, but there's another. Simplify a radical. Another rational exponent to radical form. Okay, and this is why I asked you that before. This was in the 2014 as well. This was one of the questions. Which one of those represents the symmetric property of equality? Remember what symmetric does? It just swaps the sides. So which one of those was just a swap of sides? Looks like it was B. Powers of I. Okay, solve a radical equation. I don't think you would be so challenged with that. I think that'd go pretty straightforward. Not that. Here's another. Solve a radical. Cube both sides. Come on, why is that slowing down? I think there's at least one more. There's the subtract 11, raise both sides to the 4th power. And I think that's the end of the radical expressions and equations. And in fact, there's none that are like specifically about the graphing. There's none. There's one that kind of graph shows up, but it's not actually called that. So, But you could say, number one, I think out of the first 20 questions, there was probably 6 of them were radicals. But I think the level of difficulty of those are pretty much in line with what we're getting right now. Even, you know, they could be harder, but it wouldn't be for any specific use. And that's not just like teaching to the test. That's like the Virginia has its standards of learning. You know, we're just trying to fall in line with the standards. You'll do more of this in math analysis. Okay, so now let's go to another isolate, right? So I've got to add 1. Raise both sides to the 4/3. And what is 8 to the 4/3? 16, right? The cubed root of 8, use the denominator first. The cubed root of 8 is 2. 2 to the 4th is 16. So x equals 14. So try that one. So what'd you get? 62, right? Subtract 3. And raise both sides to the 3rd power. X equals 62. Okay. Okay, now, this is where it gets like one step more difficult, which is the directions say solve, check for extraneous solutions. Where did we see that term before? With absolute values also, right? So what was an extraneous solution in absolute values? Right, you had an answer that you solved correctly for, right, but it didn't check. That's extraneous solution. So we have the same concept here. Do you remember, when was it that you kind of expected that there might be an extraneous solution? When there was a variable inside and outside, right? Well, it's the same thing here. You know, there's an x inside the radical, but there's an x outside the radical. And that's what leads to the extraneous solution. So, you know, we're going to go through the same steps, but at the end, that 4th step, check, is kind of important to do. You know, and you're lucky if it says check for extraneous solutions. So this one, the absolute value, sorry, the radical is already isolated. So what would I do? Undo it. I'm going to square both sides, right? So I need to square x plus 1. And square 7x plus 15, the square root of 7x plus 15. So on the right, we're just going to get 7x plus 15. On the left, we have to FOIL what's x plus 1 times x plus 1. X squared plus 2x plus 1. So what kind of equation are we going to have to solve now? Quadratic, right? So you're going to have to remember, okay, well, how was it that we solved quadratic equations? What should I do first? Yeah, I mean, before I could even decide which method I'm going to use, I probably ought to write it standard form equals 0, because that'll kind of give me the clue about what I can do next. So let me subtract 7x and 15 from both sides. And on the left, I've got x squared minus 5x minus 14. On the right, I've got my 0. Now, it's possible at this point you could get an equation which is not factorable. But most of these, they kind of, I think they're trying to make them so that they're not overly difficult at this point. But the first thing you would probably look for is it factorable? You know, and what would you be looking at in that equation to determine whether it's factorable? Yeah, I mean, if you go that check, you know, are there factors of negative 14 that add up to negative 5? And there are. Then it's factorable. So you should probably factor it. What if it's not factorable? What would you do? Quadratic formula, right? So one or the other. If it's factorable, that's probably the fastest, easiest thing to do. If it's not factorable, stick it in the quadratic formula. So let's see, this thing factors as x minus 7 times x plus 2. Right, that's a one step, right? Because that is a 1 right there. You don't want to make that into like the 4's middle, split the middle term, group, right? You don't want to go through all that. Okay, now what are the solutions? 7 and negative 2. Okay, but now we have to check. So let's see. I'm gonna come up here and erase this because I need to check it in the original equation. And you could see that I changed that a little bit. That's good enough. Okay, so in the original equation, if I put in the 7, right, I would get, I'm going to do it down here. 7 plus 1 equals the square root of 7 times 7 plus 15. So 8 equals the square root of 64. And that is going to be a check. That works. Okay, now we try the negative 1. Actually, negative 2. Negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So that's negative 1 equals the square root of 1. Okay, and here's where that's important. You've got to say the square root is supposed to be positive. And it's not. It's equal to a negative. I mean, this is just like with absolute value. If you got to absolute value equals a negative number and you had to say, no, it can't, it's the same thing for the square root. So that is extraneous because of that one fact. This is not true, and so that is extraneous. Right, extraneous. Okay, so I think this is the last slide, the next one. So try that one. Okay, so what did you do first? Square both sides, right? So that should have looked like this. Square and square. Now, again, when you have a sum or a difference inside the parentheses, when you square it, that's not x squared minus 1/4, right? It's x minus a half times x minus a half. That's a FOIL. And if you FOILed it correctly, you would have gone x squared minus x plus 1/4. And on the other side, we would have had 1/4 x. So, looks kind of complicated because of the fractions. But what could I do to get rid of the fractions? No. Multiply by 4, right? Because it's an equation, you can just multiply both sides by the same thing, right? Multiply all of this by 4, and then it's going to look like this. 4x squared minus 4x plus 1 equals x. And now get it in standard form equal to 0. That'll be 4x squared minus 5x plus 1 equals 0. Okay, now, is it factorable? Okay, what do you look at in this case to tell whether it's factorable? What's the difference between that one and that one? Look where I got the red 1 there, right? Because the coefficient of x squared was 1, that was a one-step process. You just had to look at the negative 14 and the negative 5, and you were done. But what do you have to do when that is not a 1? When this number here is not a 1, then what's the thinking? 4 times 1, the a times the c is 4. What are the factors of 4 that add up to negative 5? Are there? Are there factors of positive 4 that add up to negative 5? Negative 4 and negative 1. So in the end, it's factorable. Now, you could use quadratic formula. You could even use quadratic formula with the fractions involved, which Jason did, and he got the right answer. But I'm just going to factor it because it is factorable. Right? The factors of 4 that add up to negative 5 are negative 4 and negative 1. And then I group. And then I factor. And then I factor one more time. 4x minus 1 times x minus 1. Okay, so what are the solutions? So x equals 1/4 and x equals 1. Okay, but we have these directions right here. Check for extraneous solutions, which we should know because there's an x outside and an x inside. So let's see, if I plug in 1/4 there, then I'm going to get 1/4 minus 1/2 equals the square root of 1/4 times 1/4. Well, what's 1/4 minus 1/2? Negative 1/4. So, I mean, it doesn't much matter what comes out of the right-hand side. It's a radical. It's a square root. It's supposed to be positive. So this is actually 1/4. So that's not true. So that's the extraneous solution right here. So this extraneous. Okay, we could check the other one. All right, that'll be 1 minus 1/2 equals the square root of 1/4 times 1, which is 1/2 equals the square root of 1/4, and the square root of 1/4 is 1/2, so that checks. So 1 is an answer, 1/4 is not. Okay, so that was the last slide, and that's the homework.